Hello, we are here for one more lesson of this AxisVM training course. The topic for today will be a resume of the main steps that we must consider to make an analysis. So this is a little more theoretical today, but it is important to resume these steps. And if you are a little more curious about this and you want to go a little deeper, please consult our theoretical course, because you have this in detail. You have a couple of additional informations that we will not include in this video regarding the finite elements that we can use in different types of analysis, and we have also a description of some error messages and warnings that we can get when we work with this analysis and with the calculations inside the software. In the video, we will remain only on the main steps. So there are a couple of steps, and I can point 12 steps, 12 main steps. First one, we must define the geometry of the structure, the material, the cross-sectional properties of the members, support conditions, and the loads, which all of these are things that we've done in these videos and also in the examples. Second step, we need to determine the load transfer path. Third, determine load discontinuities such as stiffeners, gussets, holes. This is a little about the modeling of what we want to calculate and the structure we want to simulate. Then number 4, we must determine the type of finite elements that will best model the behavior of the structure. That is why we have different types of elements, and we must be very aware of it is what best suits to get precise results. Then number 5, we need to determine a mesh type and size for the model. We've done already also a couple of examples, and it is important this in every software that works with finite elements. The size of the mesh is crucial to have good results. So this size of the mesh have to correspond to the desired accuracy, okay, and also with the hardware we have, because a smaller mesh, it will increase the need of hardware. So you must get a balance out of these two things. Point number 6, so then we create the model, the geometry, the properties, the topology of the elements, the support conditions, the loads, whatever, okay? Finally, number 7, we need to check everything that is input, that we call data, so the accuracy and the compatibility. We need to assure that everything it is correct. Number 8, finally, we'll go and run the analysis. Number 9, okay, select the important results from the analysis, because you'll get a lot of data and probably you will not need all the data. Point number 10, we must evaluate and check the results. We can point out 3 points: accuracy and convergence of the solution, compatibility taking into account point 6D, and finally, uncommon structures shall be analyzed with other methods and other software if it is the case. So it is important to evaluate what we have and to know very well the software, so that we can expect something that is reliable. Point number 11, we need to restart the analysis with the correspondingly updated model. And I'm saying this if the previous step is not satisfied. And finally, point number 12, we must evaluate the results by all the means we have with us. So the ISO lines, ISO surface, animation tables, whatever. We have a huge amount of data we can analyze and check to reach a proper conclusion of what was studied. So these are the main steps to create an analysis. Again, see it a little better explained in our theoretical course, but for sure, if you need some help about these or other topics, let us know, and we will help you in what we can.